Company was founded in 1984 and invests in continuous research and development every year. Company is comprised of three business divisions. First is an equipment division, which main product is etch grinders in the semiconductor display industry. And second is a surgery robot division. Last is our TOF 3D sensor division. Company was listed in Kosdaq in 2005. And thanks to steady technological development and efforts, Company was selected as World Class 300 in 2016 and won the Technology Contribution Award in 2022. Then let me tell you about what our company do. Before explaining the TUF camera we use, let's find out why 3D is necessary. First of all, the primary reason is to solve the problem that cannot be identified using the 2D camera method. While image output through existing camera methods could only provide limited information, output values through 3D sensors are essential information for recognizing objects and performing tasks in systems that replace human activity areas such as robots and unmanned facilities. As it is already known, 3D vision sensors are increasingly being used in various industries. Representative examples include object outline recognition error, anti-counterfeiting, and volumetric measurement of irregular objects. The value of its use is gradually increasing to improve not only machine learning, but also deep learning capabilities in various future industries where AI is applied. Then what is the TUF 3D depth camera? It is the representative technology of CubeEye. CubeEye is the brand name operated by Company. TOF stands for time of flight, and TOF is a technology that measures the distance between an object and a camera by calculating the phase difference between the vessel's emitted light and return light to the receiver after reflecting the object. The distance value of each pixel can be measured using the calculated phase difference, making it possible to create 3D images. From touchless tabs to AR, VR headsets, robots, and self-driving cars, products that can see their surroundings are becoming more common. Camera sensors are the first technology needed to create viewable products. However, cameras alone can only capture 2D images. The real world is three-dimensional. Thus, it requires to have a depth data for the application which is related to the real world. For example, touchless tabs require knowing the distance of your hand. Robots and autonomous cars need to sense the distance to objects to avoid collisions. And augmented reality experiences require 3D maps of real-world scenes. What are the known advantages and disadvantages of TOF? First of all the advantages include high speed and real-time capability, which are important in robots. In addition, accurate and long-distance measurements are possible even in dark environments. And the low-cost compact system can be used flexibly. In contrast to other sensors, it also has the advantage of low software complexity. So what are the main disadvantages? First, there are difficulties in solar environments. And due to the characteristics of VXL, there could be scatter lights and multi-path interference. And as highly reflective materials do not reflect lasers properly, making it difficult to receive accurate data from the light receiver. CubeEye is putting a lot of efforts into software to compensate for these shortcomings. There are three main types of sensors that measure the depth: stereo vision, structured lights, and TOF. Each type has its pros and cons because the application fields in which they are used are somewhat different. It is important to select a camera that suits the purpose and perspective of use. However, among them, the strength of TOF compared to other sensors are that the working distance is the longest and the 3D imaging accuracy is implemented with an error range of less than 1% in the case of CubeEye, thus making it second most accurate after structured light. Software complexity is not complicated and the size is very compact. The cost is also very reasonable and has the advantage of enabling real-time monitoring, which is most important in the field. So let me tell you about the scenarios and main target markets in which the TOF 3D depth camera is used. In fact, the scope is not limited to a few things, but includes everything that cannot be done with a 2D camera. I will tell you about representative scenarios. First of all, 3D reconstruction. 3D reconstruction technology is a technology that restores the actual 3D shape of an object in an image. The act of taking a picture with a camera is the act of projecting a 3D object in the real world onto a 2D plane, and it is resulting in the loss of 3D shape information. For this reason, the distance to the object must be known for 3D restoration. And TOF technology is suitable for 3D reconstruction that requires accuracy. Next is collision avoidance. Collision avoidance technology can be done by various solutions such as TOF, proximity sensor, and LiDAR, and else. Each sensor has its pros and cons, so it is important to use the sensor that suits for your application. TOF is suitable for light and compact applications that require popularization, such as the cleaning robot on the page. The third is volume measurement technology. There are other sensors that can also be used for this technology, but the advantage of TOF is that it can measure quickly and accurately. In addition, measurement is possible even when an object is moving quickly, but it also has the advantage of being able to measure the volume when it is not moving. Lastly, there is pose estimation. For rehabilitation, exercise, and accurate pose analysis in each sport, distance values are obtained using a TOF camera. The person is recognized and the skeleton is set, and the movement value is quantified according to the user's movement and applied to the application. As we enter the fourth industrial revolution, many industries are choosing automation, and companies are also constantly investing in technology development to keep up. A picking solution using a robot is a representative example, and object picking is a solution for grabbing 3D objects rather than 2D objects. So TOF technology is essential. Then why TOF is essential solutions rather than other sensors? The most important aspects of a robot are accuracy and speed. By using a TOF camera for object picking, accurate distance values can be sensed to accurately distinguish objects, and real-time monitoring on a running robot and fast capturing at a high frame rates are also possible. It can be said that not only in terms of operation, but also in terms of mechanism design. The compact design allows for high hardware autonomy, and it also has management advantages at a cost competitive compared to other solutions. As you can see on the page, each sensor type has its pros and cons, but you can see that the strength of TOF stands out, especially in the robot picking market. Next is volume measurement. Smart logistics is an essential part of a smart factory. As shown in the picture on the left of the page, you see the existing system without camera is used at the speed of the conveyor belt to calculate volume, which could result in volumetric error and had the disadvantage of being unable to measure the volume of unstructured or fixed state objects. However, by using TOF technology into the solution, fast and more accurate volume measurement is possible, and unstructured objects can also be measured. The volume measurement field that adopts TOF technology is not limited to the logistics sector, but is emerging as a solution for various applications, such as measuring body shape through 3D scanning and measuring the volume of objects in silos in the agriculture or construction field. The next market is pose estimation. Fields such as body shape analysis, gait analysis, and rehabilitation exercise are representative areas where acquisition of joint angle, joint length information that can be lost in 2D camera enables identification of complex poses. It is not limited to this field and can be extended to the purpose of an action recognition such as fall detection and crime detection. Pose estimation technology is currently being utilized in the market using the skeleton algorithm based on RGB. And CubeEye is also planning to release a solution based on RGBD, which is RGB plus depth camera, by the early of next year. So far, we have talked about the scenarios in which TOF 3D depth cameras are used and the main target market. This is because we have more than 10 years of TOF business history to handle such a wide range of specialized applications. We started the TOF business around 2014 and have great pride in being the first in the world to commercialize the TOF camera. With this history of background, we launched the i200D in 2024, which shows good performance even in a solar environment using an Infineon Rear 3 image sensor. More than 10 years, we have put in a lot of effort to create strengths that are different from our competitors. First of all, we have networked with major chip makers and VCSEL makers. And in particular, we have invested heavily in the software and hardware sectors to directly design FPGA and ASIC. Thus, we have made efforts to reduce the burden on the host by allowing customers to use the depth and amplitude values obtained from the camera without additional calculations, and also have our own calibration system, post-image filter, and point cloud functions. In addition, the SDK is supported in Linux, Windows, Android, and ROS 1 and 2 environments, providing a wide range of SDK. The customer will ultimately have the respective data of depth, amplitude, and point cloud, and this data can be used to build the customer scenario and then apply it to the final application. Then why did CubeEye use Infineon's Rear 3 image sensor? In the case of general TOF, a wavelength of 940 nanometer is used to avoid interference from sunlight, and there is an issue that the light tends to be saturated in an outdoor environment in the 940 nanometer of wavelength. However, Infineon's Rear 3 time-of-flight image sensors output relatively accurate values without being saturated even in a solar environment, and it is resulting in accurate results even in an outdoor environment. While stereo, struct light, and TOF are all poor in sunlight, Infineon sensors show good performance in outdoor environments, providing new solutions to many application companies that require use in solar environments. In addition, by adding CubeEye's technology, we have been able to secure a wider viewing angle of 90 degrees than before, a long working distance of up to 7 meters. We will introduce the companies and applications that have successfully used the i200D. The first is Rendezvous Family Robot. Rendezvous Family Robot is a robot that autonomously drives inside a smart farm and performs pest control, transportation, and growth measurement functions. As Korea enters a busy modern society, the majority of young people are moving to cities, and the shortage of labor in rural areas is becoming a social issue. To resolve these issues, government support and invest in smart farms are actively taking place in Korea. In line with this, Rendezvous is attaching the i200D, which can be used in a solar environment, to the robot so that family robot can be mounted on rails installed inside the farm. The second is JMarple. JMarple is a Korean company that's developed a drone system applying artificial intelligence-based indoor navigation algorithm. Based on this technology, self-driving in loss of communication has become possible, and there is a feature that enables auto-routing. In particular, the i200D, which uses TOF technology to map even in complete darkness environments and shows excellent performance in solar environments, has attracted great attention in the market by announcing a drone capable of autonomous flights such as obstacle detection even outdoors. Triplet is a Korean company that has developed responsive advertisements using TF technology and is successfully collaborating with various retailers. The moment a customer enters a convenience store, the camera analyzes the customer's gender and age, and when the customer stops at the advertising zone, customized advertisements are shown to the customer, creating a win-win effect that encourages customers to make necessary purchases and increases sales rates for retailers. In addition, TOF technology is used as a solution to increase customer satisfaction and secure regular customers by remembering and analyzing customers' patterns and displaying customized advertisements upon return visits. In the case of crowds, RGB alone has the disadvantage of generating a lot of errors and being slow. So when targeting a large number of people, adding depth provides more accurate results. So TOF technology was applied to the responsive advertisement application. And it is drawing great attention in the market. Last is the UniUni. UniUni is a fast-growing Korean company that successfully launched an abnormal behavior detection application named Savvy in fields that require privacy protection based on CubeEye's TOF module. You can hear a detailed explanation of this solution from the next presenter, UniUni. Thanks for listening our presentation. Thank you.